Hi everyone, welcome again. Today we're going to discuss about how to calculate fixed end moment. Okay, for the first example, when you have a beam with subjected with point load, what you have to do is first refer to the table what formula you're going to use. We only have three tables that synonym to our calculation or familiar in our calculation to find the FEM. We have uniformly load and point load subjected at distance at left A and distance at right B, while there's a point load also subjected at the middle of the beam. So we have three different formula that we're gonna use in to find fixed end moment. We have the right side of the beam and the left side of the beam to find the fixed end moment. Okay, now let's look at the first example. Okay, this is the first example. You have to calculate a fixed end moment at the left and the right side. When you have a point load subjected to the middle of the beam, and for instance you have 2 meter in each side, left and right side, and then we're going to use this formula, this equation, to find the fixed end moment at left and at the right side of the beam. For the left side, we're going to use negative P L over 8, this one. Okay, or we're going to use this point load subjected to any side of the beam. If the left and the right side is not similar, still we can use this formula, the second formula. So when you have point load, we can use this type of formula, which is PAB square over length square, or we're gonna use P times L, or P times length divided by 8, and we get the similar answer if we use these two types of formula. Let's say we're going to use this formula for point load subjected to the middle of the beam. We're going to use PL over 8, and then we're going to use P is the force that subjected to the beam. So we have 20. At the left side we start negative, and the total of the length is 4. We times 4 and we divide by 8. Okay, similar also with the right side of the beam. We have P positive P times L divided by 8. P is the force, the value of the force, and the L is the length of the beam. So we have negative 10 at the right, at the left, and positive 10 kilonewton at the right of your beam. Then we also can use the second formula to find the fixed end moment when the point load subjected to the beam. So at the left side we gonna use A, the symbol is A, and the left side is B. So we have A is 2 and our B is 2. The total length is 4. This is the total length. Okay, so the total length is 4, and we're going to use this formula, negative force 20 times A 2 times B 2 square divided by total L is 4 square. We got negative 10 kilonewton meter. Okay, so we repeat, we use another we use the right side formula, which is P times B times A square divided by L square. Okay, this formula is wrong. We should use P times A square times by L. So this is the we get also the same answer, 10 kilonewton meter. Okay, so let's try the second question. So the second question, we have a beam subjected to a 2-point load. So while we have a 2-point load subjected in one beam, we're gonna use the point load formula, but we're gonna use 2 times. Okay, one for P is equal to 20, and the other one is point load when 15 kilonewton. So we're gonna use this formula 2 times. Okay, so for the point load subjected at the point of the B with not similar size, with not similar length, so we're gonna use P 20 kilonewton and P when 15 kilonewton. So we're gonna use 2 times of this formula. Okay, so the A for the 20 kilonewton is 2, and the B for 20 kilonewton is 4. This one is 4. Okay, this is B1. Okay, the fourth one. While we have a beam, a fixed end moment formula for P2, gonna use this one, P2. Okay, so we're gonna use P2 15 kilonewton using the same formula at the left. So this one is 15 is P2. Okay, and then we put a value in each formula. For A2 is 4 meter, while B2 is 2 meter. And then we continue to put each value at the fixed end moment formula. This is P1 and this is P2 side. Then we operate this, and then we get the fixed end moment at the left side. While the right side, we also use this formula at the right side, and then we put the value of each formula, and then we get the fixed end moment at the right side. Okay, when let's see our exercise. Okay, when you have this beam, and then you have to get the fixed end moment for each section. We have AB, FEM AB, and then we get FEM BA, and then we have to find FEM for BC section, BC, and FEM CB. So for fixed end moment, we have to find for fixed end moment at the AB. Okay, we just look for AB span. Okay, AB span, we have 6 plus 6 plus 2 is 8 meter. The total length for AB is 8 meter. So we have to use what formula to find the fixed end moment? For the point A to B, for the beam A to B, is we get 2 point load subjected to the beam. So we're gonna use 2 times formula, which is what formula? The second formula, because the point load not subjected at the middle of the beam. So we have to use negative P1 times by A1 times by B1 square divided by L square. And then we have the second equation, which is P2 force 2 then we have A2 times by B2 square 2 and then divided by L square. So we put the value on each formula, negative 30 times 3 times by 5 square. Okay, this is A1. A1 is 3 and B1 is 5. And the total length is 8 meter. So 8 square. Okay, use the correct formula. And then we put the value of second force, which is 10. And then the A is, the A2 is new one, is 6. Alright, is 6 meter. And then the B2 is, sorry, this is A2. And the B2 is 2 meter square divided by length square. So we have to total this. And then we get the answer for FEM AB. While for FEM BA, we just look for BS section. So BA, we're going to use the correct formula for the right side. Okay, so the right side, we're going to use this formula, which is positive P1 times A square times B1 divided by L square plus another force at the beam P2 times by A2 square times by B2 divided by L square. So we key in the value, we put the value positive 30 times by 3 square times by 5 meter and then divided by 8 square plus 10 times 6 square times 2 divided by 8 square. So get the answer at the right of the BA beam. And now we look at the BC. BC is, we have one load loading at the BC, which is the uniformly load. Okay, so when the uniformly load, we have to use this formula, the first formula, which is at the left side of the beam is negative L square divided by 12. So you only have one force subjected to the BC beam. So we have negative W times by L square divided by 12. So we put the answer, put the value here, negative 20 times L. The L of the length BC is 8 meter also. And then 8 square divided by 12. Okay, so we get the answer for FEM BC. While FEM CB, we use the formula positive WL square divided by 12. We got positive 20 times by 8 square divided by 12. We get the answer. So all unit must be moment unit. Okay, kilonewton times by meter, so kilonewton meter. And then this also kilonewton meter, and then also kilonewton meter. So this is how we find the fixed and moment. Now you have to fulfill and then you have to calculate the answer for this value. Okay, find your answer here and check with me later. Okay, so this is how we find the fixed and moment. So let's try the next question. Thank you.